3, 2, 1. Hey, did y'all see the assignment Puan Ari sent us just now?
Yep, can't wait to start the project.
Do you guys want to discuss about first now?
Yeah, that's a great idea.
Okay, so I found out that a nanoparticle or ultrafine particle is usually defined as particle of matter that is between 1 and 100 nanometers in size. The term is sometimes used for larger particles, up to 500 nanometers, or fibers and tubes that are less than 100 nanometers in only two directions. At the lowest range, metal particles smaller than 1 nanometer are usually called atom clusters instead.
There are also many areas and fields that we can apply nanotechnology. For example, semiconductors and electronics. Nanotechnology in electronics increases the capabilities of electronics devices while reducing their weight and power consumption. It increases the density of memory chips and it reduces the size of transistors that used in integrated circuits.
Other than that, nanotechnology can also be used in the energy and electric fields. Nanotechnology is being used in several applications to improve the environment and to produce more efficient and cost-effective energy, such as generating less pollution during the manufacture of materials, producing solar cells that generate electricity at a competitive cost, cleaning out organic chemicals polluting. Nanotechnology is a growing scientific field with applications in many different areas, including electronics. Some of the most commonly used nanomaterials for electronic and electrical equipment are carbon nanotubes and quantum dots, and in the case of surface coatings, nanoparticles of silver.
I also found out that nanotechnology can be used in agriculture. The significant interest of using nanotechnology in agriculture includes specific applications like nanofertilizer and nanopesticides to trail products and nutrient levels to increase the productivity without decontamination of soils, water, and protection against several insect pests and microbial diseases.
Apart from that, nanotechnology can also be used in textiles. Many companies use fabrics coated with silver nanoparticles to develop odor-free clothing such as stockings, socks, and undergarments. The properties imparted to textiles using nanotechnology include water repellence, soil resistance, wrinkle resistance, antibacterial, anti-static and UV protection, flame retardation, improvement of dyeability, self-cleaning fabrics, and so on.
Fun fact, nanotechnology can also be used in the food industry. Nanotechnology applications in the food industry can be utilized to detect bacteria in the packaging or even produce stronger flavors and color quality and even safety by increasing the barrier properties. Nanotechnology holds great promise to provide benefits not just within food products but also around the food products. Although the application of nanotechnology provides numerous advantages related to food safety and quality, at the same time it may present a potential risk not only to the human health, but can also affect the animals and the environment as well.
Besides, nanotechnology also used in the medical field. One application of nanotechnology in medicine currently being developed involves employing nanoparticles to deliver drugs, heat, light, or other substances to specific type of cells, such as cancer cells. This technique reduces damage to healthy cells in the body and allows for earlier detection of disease. The use of engineered nanomaterials, nanoparticles, offer the ability to transport therapeutics to specific sites of a disease, thus reducing the off-target toxicity of many drugs. This is especially true in the use of chemotherapeutics where off-target reaction cause serious side effects in cancer patients.
Who knew that even in the cosmetic area they use nanotechnology? Insoluble nanoparticles in cosmetic products are essentially used as UV filters or preservatives. Nanoparticles alter properties of cosmetic products including color, transparency, solubility, and chemical reactivity. Nanotechnologies allow enhanced properties in many areas of interest to the cosmetic industry, including UV protection, deeper skin penetration, and improved hydration. Nanotechnology also allows the packaging of many ingredients in semi-soluble package that break down as the product is being applied, not before.
Did you guys know that the coverage of the field of nanotechnology is very wide? This contributes to the rapid search and development on applicants on nanotechnology in various aspects of life.
As an example, a material that has become one of the main focuses is carbon derivative that is known as graphene.
Graphene is one of the carbon allotropes other than diamond and graphite, but has different characteristics from the rest. The size of graphene measures from 0.1 nanometers, which makes graphene among the most important materials in nanoscience and nanotechnology.
Graphene sheets can be converted into other materials including graphites, carbon nanotubes, and fullerene balls.
Graphene is an extraordinary material with various distinctive characteristics that can be attributed to its physical and chemical properties. Among them, graphene has high thermal conductivity, high electrical conductivity, and high elasticity and flexibility. It also has high hardness and high resistance. Graphene is approximately 200 times stronger than steel, similar to a diamond's resistance but much lighter. Ionizing radiation is also not affected. Graphene is also able to generate electricity by exposure to sunlight. It is a transparent material with high density, which doesn't let helium atoms pass, but it does allow the passage of water, which evaporates at the same speed as if it were in an open container. Graphenes also have an antibacterial effect, low joule effect, low electricity consumption compared to other compounds.
Did you guys know that graphene in energy could dramatically increase the lifespan of a traditional lithium-ion battery, meaning devices can be charged quicker and hold more power for longer? Batteries could be so flexible and light that they could even be stitched onto clothing or into the body. For soldiers who carry up to 16 pounds of battery at one time, the impact of this could be huge. Carrying less weight and using batteries that can be recharged by body heat for the sun would allow them to stay out in the field for longer.
In electronics, graphene can be used as a coating to improve current touch screens for phones and tablets. It can also be used to make the circuitry for our computers, making them incredibly fast. These are just two examples of how graphene can enhance today's device. Graphene can also spark the next generation of electronics.
The development of polymer graphene membranes are the cause of progress in graphene-based materials. A range of polymers including thermoplastics, thermosets, and conducting polymers have been utilized for membrane formation. Membrane design and performance have been found to affect by an interfacial interaction between matrix or nanofiller, matrix type, processing technique, processing parameters, and graphene nanosheet content, and functionalization. Significant mechanical, thermal, electrical, barrier, and optical properties of polymer or graphene have led to the high-performance membranes. Potential application areas of polymer or graphene nanocomposite membrane identified are for gas transport, filtration, anti-corrosion, and biomedical in addition to energy relevance.
Surprisingly, I just found out that nanotechnology is also used in materials and products that can be found around the house.
Yes, you're right. One of them are solar panels. Solar power allows people to harness electricity from the sun without directly creating waste. Photovoltaic solar cells are made using layers of crystalline silicon that lower the cost of producing efficient solar cells through nanotechnology engineering. It is less expensive to produce and allows cells to collect the sun rays across a wider surface area.
Furthermore, nanotechnology also can be found in really small and unexpected products like bandages. Bandages are normally applied to protect wounds from further contamination, but engineers are now studying new ways to enhance their antimicrobial properties using nanotechnology engineering. Incorporating novel metals, which have natural antimicrobial properties, into bandages has been proven to help combat bacterial infections. These bandages are commonly used to dress injuries that are resistant to treatment and prone to infection, like burn wounds.
It's kind of funny that this nanotechnology is even used in my sunscreen too. Nanoparticles have been added to sunscreens for years to make them more effective. Two particular types of nanoparticles commonly added to sunscreen are titanium dioxide and zinc oxide. These tiny particles are highly effective at blocking UV radiation. Besides, they also feel lighter on the skin, which is why modern sunscreens are nowhere near as thick and gloopy as the sunscreens we were slathered in as kids.
On the article, it is also said that it is also used in the making of tennis balls. Nanotechnology helps tennis balls keep their bounce for longer and makes tennis rackets stronger.
It seems like it is also used in clothing. When used in textiles, nanoparticles of silica can help to create fabrics that repel water and other liquids. Silica can be added to fabrics either by being incorporated into the fabric's weave or even sprayed onto the surface of the fabric to create a waterproof and stain-proof coating through nanotechnology.
Wow, nanotechnology is really cool.
I know, right?
That was such a good discussion.
Exactly. Good luck for project, guys. Bye.
Bye-bye.
Bye.